Estimados participantes, buenas tardes. Mi nombre es Rodrigo Arevalo, miembro coordinador del área de eventos de la Carrera de Ingeniería Civil de la Universidad de Lima. Les doy la más cordial bienvenida al tercer día del segundo Congreso Internacional VDC. En esta penúltima fecha, desarrollaremos el eje La integración tecnológica en VDC, donde contaremos con 5 ponentes internacionales de lujo de diferentes países. Juan Carlos Germano de Brasil, Adam Matthews del Reino Unido, Gunnar Eskid de Noruega, Cintia Broske de Uruguay y René Morcos de Estados Unidos. Adicionalmente a esto, quisiera comentarles que así como los 2 días anteriores, contaremos con traducción simultánea por si desean escuchar la ponencia en inglés o en español. Para esto deben activar la opción de intérprete ubicada en la barra de opciones inferior. Además, a lo largo de la ponencia pueden dejar sus consultas dirigidas a los ponentes específicamente en la casilla de preguntas y respuestas que se muestra también en la parte inferior. Sin nada más que decir, vamos a dar inicio al programa, invitando primero al administrador Juan Carlos Germano. Él es CEO del startup de realidad aumentada Construtec Augin, empresa que trabaja con la tecnología de realidad aumentada y con flujos automáticos a través de plugins para el envío de archivos de imagen en 3D, permitiendo la visualización de los modelos en escala real en el entorno. Esta exposición se realizará en inglés, por lo que si desean escucharla en español, pueden activar la opción de intérprete como mencioné anteriormente. Adelante, Juan Carlos, muchas gracias.
Hello, guys. It's a pleasure to meet all of you in this day. I'm very happy. I'm just going to share my screen. Just if I can have some feedback, if everything's okay with the audio, please.
Is everything okay?
All right. So, well, tonight we are going to talk about augmented reality. I'm very happy to bring to all of you my experience since I started to use this technology for myself, and I explain why. This is me. I'm not that strong, but I'm holding a big brick in augmented reality. And you see the reason, because I'm owner in Brazil of a big company of bricks. We do ceramic blocks and bricks. The company name is Pauluzi. I major in business and I postgraduate in civil engineering, and that's me holding the brick. And by 2014, I started to hear about BIM. In the meetings, people talking about BIM, and I wanted to know how me, a supplier, could enter the BIM. How can I use BIM for my company? And the feedbacks I received at that moment, they said, like, Juan, you have a company that you have all the details of your products. Why don't you build a library, a depository of BIM objects for your company? So we started doing this first experience with BIM, and I was very surprised because in Brazil, I guess my company was the third to launch these products. Virtual products, and I got surprised by the number of downloads the people were doing. So that was my first experience with BIM. And for a big company, it's hard to keep in the top, like to develop new things. And after that, like 2017, I was thinking like what my company can do. And then we come up with this augmented reality. I was really liking the technology. And I was thinking, how can I use this in my company? And the idea was that we are going to develop a catalog of our company in order that our clients or customers could see our products using augmented reality for mobile phones. And I will show you, I made a team to develop this, and I will show you the moment we launch this application. ele permite a gente fazer isso. Tá? Valeu. Foi muito tempo de trabalho, equipe fantástica, e a gente consegue em todo o catálogo. A minha mão tá tremendo, tá? Porque eu tô nervoso. Mas, and then we got this experience on how the people was reacting using the augmented reality with something very simple, that is a brick. I got surprised, and I was talking to all of the people, hey, what do you think about this? But all the feedbacks I received was like, I like to see your brick there, but I want to see my project. Is it possible? And when I started to experience the augmented reality, I experienced like this learning capacity comparing the 3D against 2D. And for our catalog, the videos in augmented reality, like the Harry Potter style, was more interesting than the texts. And it had a better user experience. It was a trend, and you could be used for training. And this could be further applied to several other use cases, such as projects, procedures, appointments. It could be used in the construction site, in the owner guide. It could be used in the university, where a student could present to his professor, or the professor could use the technology to show the students, and so many more, like marketing. But there was a problem. Me and my team, we never had experience with the files. Like I didn't know what was an IFC before, but we started to try doing this. It was around 9 months of development, and everything go wrong. But until the day we could really get a file from Revit and place that model in a construction site in a real scale, one-to-one. And the thing we thought, like, now that we did this, how can we make this all automatic? And when we launched this Ogin app, it was a plugin that the user could install in Revit, and with a one button, he could just send the model into the smartphone and open his project and place in augmented reality in real scale, one-to-one. We thought people would really love this, and it seemed to be very easy. But the real truth is that in the first beginning, nobody used, nobody knew how it could be used. And we had our Instagram account where we post some videos, and with time we saw that lots of people were liking the videos in augmented reality, but nobody knew how to do this. And we thought, like, oh, we need to create a tutorial about this. And today, in these days, when a person wants to do something, somebody already done. So look what happened, like 3 days after we wanted to make our tutorial.
Olá pessoal, bem-vindos ao Engenharia BIM. Meu nome é Fabrício e este vídeo é para explicar para vocês como instalar e utilizar um aplicativo de realidade aumentada chamado Auge. Olha que absurdo isso, gente. Esse é o terreno que vai ser construído essa obra, tá? Mas o objetivo agora é mostrar para vocês esse aplicativo. Olha que coisa fantástica. Escala 1:1. A gente vai caminhando durante a obra, a gente vai caminhando no terreno e a gente consegue mostrar isso para a equipe, mostrar isso para o empreiteiro, que forma que vai ser desenvolvida, qual é a concepção disso tudo, tá? Então é uma maneira de apresentar os projetos simplesmente incrível. Tá? Custo desse aplicativo? Nada, não custa nada, ele é gratuito. Tá? Então, se eu fosse vocês, eu ia correndo lá baixar, instalar, começar a utilizar, começar a testar aí com os seus modelos e dar um susto no pessoal na obra, né? Porque realmente assusta, né? A primeira vez que você olha, você fala, poxa, o que é isso? Enfim, é tecnologia a serviço de nós, projetistas, para poder apresentar nosso projeto da melhor maneira possível.
Great. So it simply appeared a tutorial explaining to the users how to use Ogin, how to use augmented reality, how to implement in their projects. And suddenly we got these lots of people trying and experiment this technology with their projects. And this was something we already validated with the bricks. And suddenly lots of feedbacks came, and I will show you, for example, an opinion of a professor that uses augmented reality in his class during these days.
We are in a new era, where virtualization is just a few clicks away. However, there is no purpose if the context of virtualization is not accompanied by an objective. I am Lee Chong Lee, professor, structural engineer, and I use new technologies to demonstrate what we have in the physical world for the virtual and mixed reality, using Synthetics conceptualization to the real implementation, with its dimensions and design validated by specialist softwares or manual verifications, both in the educational and in commercial area. The focus is not to have schedules, deviations, mistakes, or change without digital virtual planning.
Gravar aqui, vou colocar ele aqui, ó,
And now,
na minha
in
mão,
this video,
enquanto eu tô
he's really giving a
dando
class,
aula para vocês
he's lecturing
aqui, e já
to the
gravar
students
aqui,
with
vou colocar
augmented reality.
ele aqui, ó, na minha mão,
All right.
enquanto eu tô
Okay.
dando aula para vocês aqui.
All right. So with time, we saw the solution spreading into other countries. The Ogin was mainly Portuguese, so we started to change languages to add idioms into the application.
And today I'm going to take a look at how we can work with the augmented reality app Ogin. So first and foremost, I'm going to go to my web browser, and this is the website, aug.in.app.
Right. So basically today, all the contents on Ogin is created by the people who use the tool. So we can see tutorials in Spanish, tutorials in English, tutorials in Vietnam, or there's so many contents, and in case you interest, you can search in YouTube and you will see a lot of tutorials around the application. Today, Ogin is present in lots of countries, and it has straight plugins to these softwares. And we also receive IFC files and FBX files into the tool. Last year, our tool is basically go with what users say to us, what they need. So at this moment, we collect so many opinions from the people who are using, and we get better the tool. Like last year, they really wanted to click in each object and get the BIM information while using augmented reality. So it's something we add into this experience. In the left video, it's a construction site where they join all the procedures explaining how each task should be done using augmented reality. We add the possibility of textures and render, also to sequence projects in AR, while you can see something going on in advance. And we needed to find a way to make possible to federate a project. This was something everybody was wanting, to see more disciplines, to see more details from the project. So we developed this. And on the right video, they show a functionality that we did to make the model aligned into the real world. So a person get a paper inside the project, and then when he aims the paper, the model turns on aligned into the real world, like this video on the right.
Esta referência, colei atrás da placa. Quando eu miro nela aqui agora, ele já encontra o modelo, já coloca na posição correta, na rotação correta e mostrando aqui também todos os parâmetros, né? Inclusive em escala 1:1, tá vendo? Ó, BIM Data. Agora a gente consegue enxergar os dados IFC. Conforme eu vou movimentando agora, olha lá, já estou dentro aqui da edificação. Muito bacana, né?
All right, so the other thing we see with augmented reality is that it has so many possibilities, and we see with the videos, like people doing meetings in the beach, really they're discussing about the project because the project is in the pocket, like in the mobile phone. And the second video, the person is trying to show that the big truck of his client would fit in the place. And in the video of the right is that augmented reality can also be fun. It's great. And in this video, it also can be very serious because this is a very big company in Brazil, and it has the opinion on why they're using augmented reality.
Mi nombre es Estefanía Carré y soy coordinadora del área de innovación y tecnología en la construcción de la empresa Tegra Incorporadora, una de las mayores compañías del sector inmobiliario en Brasil. Nosotros utilizamos realidad aumentada en nuestros edificios para varios fines, y en este caso utilizamos el aplicativo Augin para la validación del departamento modelo de uno de nuestros edificios. Este es un proyecto que nació a través de una demanda de nuestros arquitectos de proyecto que ya usan BIM en su día a día y que detectaron que el uso de realidad aumentada facilitaría el proceso de validación de las instalaciones. De esta forma no habría necesidad de tener que estar abriendo muchos proyectos y planos al mismo tiempo para entender el proyecto directamente en campo. Con la digitalización del proyecto de validación conseguimos analizar nuestros departamentos prototipos de una forma más rápida y eficiente en comparación al método tradicional.
All right, so we were really focused on the people wanted to see, because the BIM models are getting more complex. So, and we are trying to open them in a smartphone that is a not very strong machine. So we needed to do some great advances towards the file opening, and it took us to launch also a desktop application of Augin. And this is a video of Augin desktop application where the user can implement the reference tracker in order to use in augmented reality in the site. And this is a massive file in Brazil with 52 links, almost 3 gigabytes project here in Porto Alegre. And with this Augin version for desktops, you can see the information of each object, and you can walk to the model with an avatar, and also you can run too. People are saying it's sort of a GTA of AEC, and also use a drone. And it's a tool that we did for presentation projects, and we will move on into multiplayer where users can have several avatars and join meetings to discuss projects or present projects. The next steps for our application is also deal with BCF opening and BCF export. Suppose you are in augmented reality and you want to send a BCF to somebody that is doing the project. And we also want to implement documentation while using augmented reality. This is something the people suggest us. And we work on the premium version next, and especially with VDC, that in 2018, I saw the first presentation of VDC in Brazil. It was done by Leonardo Hirschmolen. I really liked his application, and I started to be curious about VDC. As I said before, I'm learning about BIM, I'm learning about VDC, I'm very interested, and I see augmented reality can be used and can be a great helpful with the ICE sections, while a person can just place the model in the front using a mobile phone. So it's something that no company, no person needed to buy extra equipment, and they can check if the size is okay, if it looks nice, or how can we correct something. I think it's a great tool for collaboration also, that you can have more people around discussing about the same project in the same page. And like I thought, when a person in the construction site is trying to see lots of views from the project, they're trying just to render a scene in his brain, because he needs to put all those drawings together in his head. And I see augmented reality is one of the technologies that can just place the model in your front in the real scale, and we can diminish the understanding time. And this is really something that VDC get together about reducing the latency and get to where it needs in the right time. So because mainly on the construction site, maybe that person that is trying to understand the drawings, he didn't have all the training that the people who did the project. So we are seeing that is getting to this. So I don't have much time, but I want to say that I'm very, I really like the VDC methodology. And I hope Augin can hear the techniques, the experience of VDC, and we also wants to contribute with the ICE sections, and also reducing the latency on the project, making the constructions flow better. So I really like to thank all of you for hearing my presentation. Augin is open for everybody, and we want to make a great work around the construction site. So thanks for the invitation. I hope you like the theme, and I'm available later for questions. So thank you very much.
Perfecto, Juan Carlos, muchas gracias. Una manera bastante interesante de aplicar el BIM, no solamente a una empresa, sino también como ayuda para otras empresas. El hecho de tener un repositorio de realidad virtual y guiado es una ayuda bastante grande. Muchas gracias por la exposición. Recordarles a todos los presentes que las preguntas las pueden realizar por la casilla de preguntas y respuestas y serán respondidas al final de todas las exposiciones. Ahora es momento de invitar al PhD Adam Matthews, director internacional del Center for Digital Build Britain y presidente del Global BIM Network. Actualmente, con su equipo, asesora a los responsables políticos y a los comités nacionales sobre estrategias para fomentar la digitalización del sector de la construcción. Debo recordarles nuevamente que esta exposición se realizará en inglés, por lo que si desean escucharla en español, pueden activar la opción de intérprete, como ya fue mencionado anteriormente. Adelante, Adam, y muchas gracias.
Muchas gracias, Rodrigo. It's a pleasure to be with you this evening. I just want to check, first of all, that you can hear me okay. Is this okay for the interpreters?
Podemos escucharlo y verlo muy bien.
Okay, I'm going to assume that that's okay for everybody. Perfect. Okay. Well, it's a pleasure to be with you. As I said, I can see my presentation is going to be very much in line with and consistent with your discussion. The first thing to say is that my presentation is really going to focus on the global perspective. I'm going to do three things in this presentation. I'm going to talk, first of all, about the big picture, the global picture of what's going on. And I'm also going to talk a little bit about why it's happening. Why is there such a large global conversation between governments across countries and between industry, as we can see here this evening. I'm also going to talk briefly about what this means from a future perspective. Where is this going? What does it all mean and lead to, and how will it help us? So with that, I'm going to get started. As was mentioned, I am based out of the UK. I lead a team that supports and works with governments around the world. We've worked with governments across and industry across Europe, Latin America, Asia, and more recently the US as well. Speaking of the US, I'm also delighted to make note of the fact that just this week we've signed a bilateral MOU, a Memorandum of Understanding between the UK and the US to work together, to collaborate, to support the US National BIM program, which is being developed, and also look to see how we can align standards and learn from each other. This is the most recent of our collaborations. We've collaborated, as I said, with between 30 and 40 countries around the world. As you'll recognize, I'm sure, on the screen here, Santiago there. In Chile, we've also got Hanoi, that's Vietnam in the top right corner, and over 20 countries in Europe that we've collaborated with for a number of years. So this is the idea I want to discuss with you. It was an idea that frankly I could barely have dreamt about even 5 or 6 years ago, that we'd be now in a position where we are collaborating around the world, having conversations like we are this evening. And it makes me immensely humble, actually, just how much we can learn from each other on this great topic of how we can bring digital to our industry. So a quick look back in time. Here's a view from between 2010, 2015, around the idea of national BIM programs. What was happening back then? Not that long ago, 2015 was only 6 years ago. What was happening? Well, in the US, there were a number of owner level BIM requirements. And in the Nordics as well, very similar. There were some owner level BIM requirements. In Singapore and the UK, there was this idea of an emerging national program, a way to bring together government, industry, and academia. And that was really not that long ago in construction terms. I'm sure we all know how large, diverse, and huge this industry is. So that was only 6 years ago. Now, look at where we are today. We have in Europe, around 15, 16 programs, national BIM programs. We have a regional group of 27 countries, 27 national programs working together in the EU BIM task group. And in Latin America, you of course have had the fastest growth in national BIM programs over that period. And of course, Peru, I will talk about a little bit about in a moment, has gone through tremendous growth since the beginning of 2019. Again, only two years ago on this agenda. So incredible progress has been made. And there's also a regional group, as I'm sure you're aware, with the regional network of governments supporting each other and collaborating on this agenda of BIM introduction. In Asia, again, similar, there's been positive developments there, more recently with Vietnam, who we've worked very closely with, who have a national program. It's based on some ideas from the UK as well, and other countries. And we've learned a lot together, actually, over the past 2 years that we've been collaborating. So this is a tremendous change to where we were really not that long ago. A quick word about who we are. The Centre for Digital Built Britain has an objective. Its objective is to help support the digital transformation of the built environment. It's really that simple. We have a domestic agenda in the UK, which is around driving not only the use of BIM as a way of better information management for organizations, but also to advance that leading edge, to advance the industry, to innovate and look at developing things like national digital twins and to support the innovation of the sector from a research perspective. So that's been a 3-year program, and it still has another more time to go. It's part of the Construction Innovation Hub, which is about transforming the construction industry. And that also looks to bring in other ideas around procuring for better value and a whole range of different ideas, bringing manufacturing into the construction industry as well. So why? What's happening? Well, it's really interesting when you look at the transition over that period of how BIM has become a central idea in many governments as to how to improve the construction industry, how to improve the output of the industry. This is an example from Peru, one very close to my heart. It's the Reconstruction Authority, and it's the reconstruction following El Nino in 2017. A hugely important program, bringing communities together and also obviously providing much needed infrastructure and support, social infrastructure and economic infrastructure. And what was recognized here is that along with other methodologies, building information modeling can help to support better outcomes, can help to reduce waste, errors, and that translates for government into delivering more infrastructure, getting better value for money, enabling communities to be better connected into society. So this is a real big picture idea that BIM, as we've seen from our previous speaker, is a technology on one hand, but it's also a process. And it's also about using information as a decision support tool. It's an incredibly powerful transformation that the industry is going through right now. And it's why governments are getting involved to encourage it. Another important agenda idea, which El Nino, the reconstruction from El Nino is a great example of, because it helps to support the UN Sustainability Development Goals. The Sustainable Development Goals are based on the idea that we need to work towards an environment that works for people, and it addresses some of our challenges as a society, including poverty, better education, inclusivity of communities, and so on. And infrastructure, although infrastructure is identified as one specific item, I see it running across a range of them, if not all of them, actually. So a quick look at the collaboration with Peru. We've been talking about collaboration here in this session, and this was started in 2019 between the UK government and the Peruvian government. It was signed officially here by our ambassador and also the Minister for MEF, Ministry for Economy and Finance. And this is really about helping Peru to improve its infrastructure, to help deliver more infrastructure for better value for money, but also improve society and improve industry at the same time. This is a great example of that collaboration. It has to be a collaboration. It always is about collaboration in the industry. And this is a great example of that, as you can see here, bringing together government representatives, public procurers, industry, academia, technology providers. There's a whole range of different stakeholders that need to be consulted into that vision. And what does that vision look like? Well, for Peru, it's described in this plan. There's an idea that over time, progressively, we can introduce BIM onto public sector projects for social infrastructure and economic infrastructure in order to get better outcomes for Peru and for its people. It's making great progress on that plan. This was updated very recently with the amazing news of progress with Peru's transition of the ISO 19650, which describes building information modeling really as a process. It describes it as better information management. And I'm sure that there is a linkage, a very strong one, between that idea of the ISO describing BIM as an information management process and a decision support environment for projects, for organizations, and ultimately for the country. And that is what interests me as well out of this conference, is what that linkage looks like. Great to see that it's been introduced into Peru by the great work by the university members, as well as many others that have been consulted. And of course, Alexandre has been instrumental in driving that. So congratulations to him and his team and to everyone involved in that work. There's lots to do, of course. That's just beginning the work. There's all the work here to actually ensure that that's adopted and that it's put into practice, not just one project, not 5, not 10, but 100, 500, and that will take time. We must be patient, of course. I know that from the UK experience, that it does take time. It is a big industry, a fragmented one, and it does move slowly, as we all know. So lots of opportunity ahead. And of course, it is, as I said, a collaborative process. I'm sure that Peru will continue to find support with the LATAM network as well. And there's much to do in terms of capacity building. We've started with a program supported by the UK Foreign, Commonwealth and Development Office and supported by the Construction Innovation Hub. We've supported nearly 800 public officials with organizational level training around BIM, understanding the organizational change that goes with that, and how to introduce it into procurement so that procurers can ask for information that they'll use in the life cycle of the project and the life cycle of the asset. So real macro idea around BIM. So lots of progress made, but clearly there's more to do in Peru. And I'm sure there are the people on this call to help get there. We need to work together. We absolutely need to learn together and work together. We need to, as we can see here, pedal together. This is the idea of a peloton. It's the idea that together we can actually go faster as a community. And I fundamentally believe that. And I've seen it. I've absolutely seen it. So this is the idea that we bring countries together. We bring the national programs together with the regional programs as well. And we've now seen the launch of this global BIM network. Back in March, it was launched. There were over 2,000 people attending these events. And it's supported by not only national level governments and representatives, but also organizations like the Inter-American Development Bank, the Asian Development Bank, and the United Nations Operational and Project Services team as well. So a great opportunity for us all to learn how this works, how this adds value, how we can accelerate this change. If you'd like to know a bit more about this, then please do look at the website, go to globalbim.org, and there's lots of information there at the national level, the organizational level, and the project level as to how BIM has been introduced. And you can also sign up on that website as well. So I'm turning towards the conclusion here. I think it's becoming self-evident that actually we are a relatively small industry in the big scheme of things. We have huge potential, but it's a small world. We can all work together to align some of that language. I said at the beginning that we do have this ability to collaborate together and learn from each other. What we're seeing now is some of those standards start to align. Countries signing agreements with each other, as I mentioned, with the agreement between Peru and the UK, and between the UK and the US, just announced this week. What it means for us as individuals and as countries, well, I think that by aligning standards, by creating some common terms and common ideas for this, I really believe that that will drive our skills and capacity. It'll make the industry more attractive for younger people to join as well. It will drive that big wheel at the top, which is about closing that infrastructure gap, supporting that green agenda and sustainable development goals, and also growing trade. And I really think that that is already happening, as we've seen with some of the work between the UK and Peru and other countries as well. So I leave you with that idea. I leave you with where I started, which is that this is making a real difference. And I want to thank you for holding this event. It's quite late here in the UK, but this is really a truly global conversation. Thank you very much for your time.
Muchas gracias, Adam. Perfecto, una gran exposición, resaltando siempre la importancia del trabajo colaborativo y el trabajo constante y progresivo. Informarnos también un poco de cómo va Perú con el BIM. Y bueno, muy interesante. A continuación, invitamos al ingeniero Gunnar Eske, mentor senior del VDC Noruega. Él es ingeniero civil con licenciatura por la Universidad de Stavanger. En sus 30 años de carrera tiene experiencia en modelado 3D para el sector de petróleo y gas, gestión de instalaciones e integración de datos CRM. Bueno, el día de hoy contamos con muchos ponentes internacionales, por lo que su exposición también será en inglés. Y si desean escucharlo en español, ya saben que pueden activar la opción de intérprete en la parte inferior. Muchas gracias y adelante, ingeniero Gunnar.
Thank you, Rodrigo, and buenos tardes, Lima. Thank you, Alexander and Omar, for the invitation to speak at this second International VDC conference in Lima. I'm very honored. And I've been following your work for the last couple of years, and I must say I'm very impressed by the level of VDC that we see from the projects in Peru. So thank you for sharing with us, and thank you for putting together this great conference. And please excuse me if I'm a bit tired. It's in the middle of the night, but I'll try to do my best and participate as good as I can. Hopefully you all see my screen. As you said, I'm Gunnar Skeie. What can I say? I'm a builder at heart and by heritage. My father was a carpenter, and I spent all my summer holidays as a student working in construction, and I guess that ignited the flame for the built world and the interest of creating physical things. But technology has always been at my heart as well, and ever since I experienced the first encounter with a 3D model in the early 90s at the shipyard in Stavanger, where we were building oil platforms, I saw that this is the way. This is what I gonna spend my career pursuing. So I now work at a company called VDC. VDC is a technology startup from Stavanger, Norway. We are targeting the construction and real estate industry by our two main product line, Life at Work and Life at Site. Where Life at Work are all about smart buildings, Life at Site is about everything happening before the building is complete, or how to build smart. VDC was established in 2018, and we are currently about 90 employees, where 10 of them are in the VDC department. One of the things that led me to VDC was their unique combination of digitizing and domain knowledge. So finally, we could develop the tools that we always have been missing in our project. Before I came to VDC, I worked for a general contractor called Congreso Smith as a BIM manager. And BIM introduced a complete new way of doing our work. We simply needed to find better ways to utilize the new technology, and we was on search for how we could utilize the BIM models and the new technology in better ways. So the first time I heard Martin Fischer speak about VDC at the conference in Norway in 2014, I knew that this is something that we have to investigate. So luckily we could manage to convince our managers to send 4 of us to California for the next VDC certificate program. This led to several VDC programs in Stavanger, co-hosted by Congreso Smith, and in 2019 I was one of the mentors at the first large-scale VDC program in Norway, and I'm currently a senior mentor at the second large-scale program. So finishing the second large-scale program, we would have educated 400 people in the VDC methodology. And as you probably have heard in a lot of times during this conference, VDC is all about working together using technology to achieve high-performing building. This is also the foundation behind all the things that we do at VNE. This is how we, this is the basis of our ideas and how we want to develop the tools that we find are missing in the industry today. At one of our visits in the US, we had several very interesting conversations with DPR and especially Dean Reed. And he once drew a sketch for us to explain some basic needs in the project execution. So this resonated very well with us, and we used that to shape our thoughts on how to develop tools to support our project execution. It's all about moving from the unknown to known, figuring out what the client really needs. Here, it's about speed and alternatives. Can we create as many alternatives as possible, as fast as possible, and be certain enough about the cost and the time to build what we suggest? When we know what the client needs, we want to move from known to done, as safe, as predictable as possible. So the focus shift when we get into construction, now it's predictability that we are aiming for. And during the entire process, we collect data for continuous improvement so that we can be even faster and have more alternatives in the next iteration of our execution, and we can be safer and more predictable at every iteration, whether it's the next week or the next project. And this has been the basis and the foundation of what we have created at VNE. And I'm very honored to share with you for the first time ever in history the new product name Life at Site. It just got official today that we have acquired this product from my former employee, and we had a special privilege to announce it here in Lima before anyone else get to know. So if you speak to any Norwegians, please don't tell them about this until tomorrow. Life at Site is actually a suite of software that we've developed. One software called Form, which is all about speed and alternatives to develop the project, and Build, which is how to manage construction, and everything is built from what we call bricks. I'll get into the details in a couple of minutes. We often, at least in Norway, we hear about from project managers that all projects are unique, and especially you can't compare my project to the other project because we have this and this. But is it really so that all the projects are unique? Take this random building from outside Stavanger. Of course, they have to deal with the foundations and the superstructure and the roofing and the climate wall and the facades and the landscaping and the groundworks. That's That's some of the categories we've found that we can see in all projects. That's something that we have to find a solution for in every project. And it's not that many of these categories, but we say that for each category, we need to find an element serving or solving the needs that we have. So for this example, it's showing a solution or an element for superstructure. And for each category, we say that we should have like 4 or 5 elements to solve the needs for that project. In the beginning, there was a lot of opponents from the project developers that we need to have more alternatives. And then we said, okay, but try to narrow it down to like 4 or 5 alternatives, and then we can practice and do these over and over again and become really good at those 5, and make sure that you spread the variation of the elements so that you cover the needs that you have in a standard project. So that when you solve, for this example, showing hollow slabs supported by steel beams and columns, you have selected a solution that would work in this project, and you have selected all the knowledge from the company that you have built over the last years. Sorry, lost track of my script here. So bricks is the foundation for everything in our solution, and it's a visual representation of all decisions made in the project, and it's also a structure to enable us to capture as-built data from the site when using these to do the calculations. We have used bricks to build form, and that's a tool to calculate while you develop or while you make decisions. So as opposed to all the other calculation tools that we have seen using BIM, the other calculation tools calculates what's in the model. We use this to say, this is the decision, this is what we suggest to build, and this is the price, and then we model. So this is just a visual representation of all the decisions made in the development of the project. We see that this is a great communication tool. Certainly, there's a larger crowd that could be part of the discussion. They can understand what is the basis of the cost, what can we change, why is this cost, etc., etc. What kind of decisions have you made in the project? And we also see that this quickly adds to the company library of knowledge. We see that the sharing of information or knowledge or experiences between projects really speeds up when you share this in this visual way. So far we have added cost into bricks, because we started off with the ambition that we should create a calculation tool that could calculate any building in less than 4 hours. And that's still a working target for us to reach that, and we think that that's achievable to do, and of course maintain the same precision as we have today. A typical calculation in with traditional methods is about 3 weeks. Most of that time is waiting for response in the market to send out quotes to the subs and wait for their response in that. So as a client, it's a pain to have to wait 3 weeks to check out whether your design choices pays off or not. So we need to be able to give instant answers. And as you can see from the graph in the middle, that's showing the cost development for one element used in various projects. And I can assure you that you get some really interesting conversations when these graphs are shared between different teams doing bids at the same time in a company that is that have a lot of offices where people not necessarily speak to everyone every day. You get these conversations on how can they do this this element as cheap as this, and then they phone up and check out what have they done, and then you can exchange data in a very rapid manner. We also added just a description tab just to add notes. What's things that we discovered using this method? What did we have to do? Which kind of reports did we have to make to create this solution in that project? So that's also a new channel for sharing experiences across bid teams and across projects. So this has really served the point for us at the moment. Currently, we are working on the design to also keep the schedule recipes for the elements as well, so that when we develop a project, we get price as a consequence of the development, and we also would get the schedule or the first versions of the schedules as a consequence of our development. We also have, when we come into construction, we have a tool called Build, Life Inside Build. That's a tool that combines the 4D BIM with the Last Planner system. And it's the same collaborative process as we know from Last Planner. I know that a lot of you guys in Peru is excellent in executing Last Planner. I've seen from various VDC reports presented. So I guess there's a lot of people familiar with that system. But this is our most mature product. This is the product that is that has the most use at the moment. And our aim here was to combine the simplicity that we all experience with the sticky note schedules with the power of having a 4D BIM in the background. So we have created one integrated schedule with tailored views to serve the purpose that we see that we need in project execution. So the top left picture is showing an overview where we have zoomed out, and you see the schedule with the milestones marked as diamonds, red or green. Green means that the milestone was met. Red, closed red, means that the milestone was not reached, and open red means that there's a predicted delay for this milestone. And at the top right, you can see the crew foremen discussing the weekly detailed schedule, the work plan. And at the bottom left, you will see an illustration from a 4D BIM that's behind the scenes. So everything here is built on top of Synchro 4D, and everything is one schedule. So there is all the weekly look ahead, or the bi-weekly look ahead schedules, and the weekly schedules, and the daily work operations. Everything is in the same schedule, so everything is updated. So when you finish a task, it updates the Synchro model. And the beauty of it is that this can be done without increasing the management on site. So every trade participate in the enrichment of the schedule. Here shown by example of our trade project manager preparing for the look ahead meeting. So he can easily select his trades activities for the coming period, and he can change the visualization and showing which work packages is not sound, and he can go in and he can work on the constraints lacking for that work package to be sound. So this was something that one of the first effects that we saw from the system was that the look ahead meetings changed from being a reporting meeting to becoming a collaborative meeting. So instead of every trade talking about we have this is sound, this is sound, this is not sound, we can now figure only concentrate on multi-trade issues where we need to collaborate to avoid obstacles in the coming session. I would say in the way that Last Planner is meant to be. I think the look ahead meeting is probably one of the best structure in the Last Planner, and this really adds value because you can have the look ahead process as we know it, but it's always powered from the BIM, so that you have the quantities and you have what's going to be built and where it's going to be built and who's going to build it and when is it to be built. All of these solutions are delivered through what we call a business platform. That's a tool for integrating back-end systems. Basically, what we have done as project managers for the development is that we have focused on the business layer, the blue layer in this figure, meaning that we could focus on how we would like the process to be. What kind of data do we need? How is the data gonna work for us, rather than how we were used to with other tools that we had to work for the data, and we had to work for the data to be adjusted to the process, or we had to, even worse, adjust the process to be able to get the data that we wanted. So This is a huge liberation to be able to say that this is how we want the application to look. For those of you that have seen Synchro 4D, you see that it's, well, not to say anything bad about Synchro 4D, but collaborative planning on our smartboard is not the strongest side of Synchro, but here you can have both. You have the Synchro or the schedule engine at the bottom, and you could do the collaborative planning by swapping or moving the sticky notes back and forth to do your planning. Sorry. So to wrap it up, live at site, new launch coming for the rest of the world next week, but for Lima, Peru, we do exceptions and we do it tonight. It's all about creating alternatives fast in the development phase. Do that in a visual manner based on your knowledge data. That's the product called Form. When we come to the build or the construction phase, we have to do that in a safe and predictable way. That's the tool called Build, and everything is built on bricks, which is the element or the decisions that we have to take for the entire project. So thanks again. Thanks again for listening to what we have to say. Unfortunately, I'm not able to make it to the end tonight. It's almost it's 2:15 in the middle of the night, so I need to get some sleep before work tomorrow. But if there's any questions, don't hesitate to email me. I will try to answer as best as we can. My email is there on the screen, and thanks again for inviting me to this fantastic conference, and best of luck for the rest of the remaining program. Gracias.
Muchas gracias, ingeniero. Perfecto. Una muy buena presentación y bueno, gracias por tener el honor de dar el lanzamiento oficial del Live at Site en el Congreso VDC. Una muy buena iniciativa tecnológica que, bueno, nuevamente nos recuerda la importancia de un buen planeamiento y el cumplimiento de procesos. Bueno, como el ingeniero ya lo mencionó, no va a poder asistir a la última ronda de preguntas, por lo cual pueden hacer las preguntas vía email. Y bueno, siguiendo con el programa, ahora damos pase a la presentación de la PhD Cynthia Broske, investigadora de temas VDC. Ella está actualmente a cargo de una investigación bajo la supervisión de Martin Fischer, quien también ha sido ponente en este congreso. La investigación está enfocada en Virtual Design and Construction y la implementación de la robótica en la construcción. Lamentablemente, ella no va a poder acompañarnos en estos momentos por cuestiones de horario. Por ello, estaremos transmitiendo la presentación que previamente grabó para esta fecha. Sin embargo, nos podrá acompañar en la ronda de preguntas, así que no duden en dejar sus consultas en la casilla de preguntas y respuestas. Para esta exposición será lo opuesto, ya que es la única que tenemos en español, y podrán escucharla con traducción simultánea si es que desean hacerlo en inglés. Muchas gracias y bueno, vamos a proceder a transmitir su presentación.
Hola, buenas tardes. Un gusto poder compartir esta tarde con ustedes. Mi nombre es Cynthia Broske y trabajo con el profesor Martin Fischer en SAIFI, y hoy quiero compartir con ustedes un poco de nuestra investigación en robótica para construcción. En los últimos 5 a 10 años hemos visto un gran desarrollo en robótica para construcción, en parte gracias a avances en computación y en hardware que han permitido el uso de robots afuera de fábricas y en espacios no estructurados, como la construcción. Dada esta nueva realidad, las constructoras tienen que entender cuándo esta tecnología va a ser aplicable para sus proyectos, cómo seleccionar el proyecto que maximice los potenciales beneficios, a quién involucrar y con qué proceso, y cuál va a ser el impacto en la seguridad, en la calidad, el cronograma y el costo. Pero mediante nuestra investigación vimos que no había una forma consistente de mirar a distintos robots para proyectos, y estas decisiones se volvían incluso más difíciles cuando por parte de la constructora obviamente no tenemos tanta experiencia utilizando robots en construcción, entonces hacía difícil poder evaluar estas decisiones. Entonces, para poder analizar algunas de estas cuestiones y de cómo los robots van a afectar la producción de la obra, nuestra investigación desarrolló un Robotics Evaluation Framework, un método para evaluación de robots en construcción que pueda ayudar a las constructoras a evaluar distintos robots para proyectos particulares en obra. En estos casos comenzamos, para realizar el framework comenzamos con 3 casos iniciales, que son los 3 que ven aquí debajo, y también analizando la literatura del tema para entender cuáles son las variables importantes, y terminamos dividiendo el análisis en 2 partes. En primera instancia, las variables independientes, por ejemplo, variables que como una constructora podemos influir, como el producto, la organización y el proceso. En primera instancia, el producto, podemos decidir en qué obra utilizar un robot determinado, y eso muchas veces tiene que ver con decisiones acerca del producto físico en sí, las dimensiones, el alcance, y ver que haya una compatibilidad entre el robot y la obra. Luego la organización, a quién involucrar y cómo. Tal vez en algunos proyectos vimos que se necesita mayor atención sobre VDC para poder utilizar el robot en obra. Y por último, ¿cuál va a ser el proceso? ¿Cuál es el proceso manual y cuál es el proceso cuando utilizamos el robot? ¿Qué tipo de información necesita el robot? ¿Cuál es la forma de mantener la calidad? En algunos casos vimos también que teníamos que mapear qué tipo de integrante iba a proveer qué tipo de información para el robot, y que esto era importante también poder planificarlo. Una vez que determinamos que la obra seleccionada y el robot son viables, podemos evaluar cuáles son los efectos en la seguridad, la calidad, el cronograma y el costo, y finalmente poder dar recomendaciones acerca de deberíamos adoptar este robot o no, y por qué, y cómo también eso se traduce a cumplir algunos de los objetivos del cliente y del proyecto. Mi idea de hoy era también poder compartir, una vez que terminamos estos 3 casos iniciales, quisimos ampliar y ver cuáles eran los resultados de utilizar este mismo método de evaluación para otros 10 robots en construcción, y también comentar un poco sobre hacia dónde está yendo la investigación y los próximos pasos para este año. Pero antes de eso quiero también tocar la conexión con VDC, con el método VDC. Muchos de ustedes ya me imagino que están muy familiarizados con este método, así que igual voy a ir un poco rápido en esta parte, pero también hay varias similitudes entre el método que acabo de describir para evaluar robots en construcción y cómo también podemos relacionarlo con el VDC Framework. Obviamente siempre comenzamos con los objetivos del cliente, porque es que el cliente está haciendo el proyecto, y acá podemos ver algunos objetivos de usabilidad, operabilidad, sostenibilidad, y que también luego se traducen a objetivos del proyecto en cuanto a seguridad, calidad, cronograma y costo. Por ejemplo, podríamos tener ciertos targets como 0 horas perdidas por incidentes en la obra, $0 sobre el costo del presupuesto, las inspecciones que todas se pasen de forma satisfactoria en la primera vez. ¿Y cuáles son las herramientas que tiene el equipo del proyecto para alcanzar estos objetivos? Son básicamente ICE, BIM y PPM, como todos ustedes también están muy familiarizados. Voy a pasar rápido esta parte, pero básicamente hablamos de a quién estamos involucrando, cuáles son las estrategias para integrar la organización, cómo se van a dar las distintas ICE sessions para coordinar el trabajo, y de forma del producto también qué tipo de información necesitamos, en qué nivel de detalle. Y finalmente en Project Production Management, planear cómo van a ser las distintas comunicaciones entre los participantes y a quién tenemos que involucrar en distintas partes del proceso. Y obviamente parte de este proceso lo acabamos de describir en el Robotics Evaluation Framework, en el cual empezamos con las variables independientes de Product, Organization y Process, que claramente tienen una fuerte relación con ICE, BIM y PPM. Y luego, una vez que tomamos estas decisiones, podemos medir cuál va a ser el efecto en la seguridad, calidad, cronograma y costo. Y luego vamos a dar una recomendación, pero queremos también poder relacionarla nuevamente con los objetivos del proyecto y del cliente, y eso también hace que ciertas variables puedan ser más importantes según cuáles son los objetivos del proyecto. Explicándolo desde otro punto de vista, podemos comenzar, si quisiéramos utilizar el framework VDC también para evaluar un robot, podríamos comenzar desde los factores controlables. Por ejemplo, en realidad utilizar el robot ya es un factor controlable. Queremos utilizar, por ejemplo, un robot para perforaciones en concreto, y vamos a hacer todas las perforaciones de 4 subcontratos en 4 zonas de 50 metros cuadrados. Y al mismo tiempo podemos tener objetivos sobre qué tipo de información vamos a necesitar, que también son factores controlables, como tener un Building Information Model a un nivel de desarrollo 400. Y luego eso se va a traducir a Production Metrics, como reducir el trabajo extenuante en cada zona gracias al perforado automatizado y no manual, y también conformar el monthly schedule. Y finalmente eso se traduce en outcomes del proyecto que podemos medir mientras vamos avanzando en la obra, que pueden ser, por ejemplo, no se perdió ningún día por incidentes en perforaciones, y al final se terminó reduciendo el schedule en un 10%. Y finalmente esto se traduce a un objetivo del cliente de abrir la obra en tiempo. Ahora que ya relacionamos un poco y tenemos un mejor entendimiento de cómo podemos utilizar el Robotics Evaluation Framework, también en relación al VDC Framework, quiero también comentar un poco de los resultados de utilizar este método para evaluar 10 distintos robots. Para poder realizar este análisis, colaboramos entre 2 universidades, la Universidad de Stanford y Universidad de Lima, con estudiantes que nos ayudaron a llevar a cabo los 10 distintos proyectos. Involucramos 11 constructoras, 10 robots en 8 países diferentes. Quiero contarles un poquito más en detalle sobre 2 de los casos que estudiamos para Lima. Uno fue con Productiva. Este es el proyecto Alta, que es un proyecto residencial en altura, que se encontraba en el 5º nivel estructural de construcción. Y el análisis se enfocó en la movilización de material, de alrededor de 700 metros cúbicos. Y para eso estudiamos la empresa Safe, que es una empresa basada en San Francisco, dedicada para la automatización de maquinaria de construcción. Y básicamente ellos pueden tomar cualquier maquinaria tradicional y le implementan un módulo de inteligencia artificial, y en este módulo se encuentra, le dan la capacidad a cualquier maquinaria de poder trabajar de forma autónoma, similares a los autos autónomos que vemos en la calle a veces o en las noticias. Vimos que tenía un costo equivalente. En este caso la seguridad era la primera motivación para utilizar este robot, y en el futuro vimos que pueden haber mejores resultados si logramos tener más de un operador manejando más de una maquinaria. En este momento, si bien logramos sacar al operador desde adentro de la maquinaria, y eso obviamente tiene beneficios desde el punto de vista de la seguridad, igual tenemos un ratio de 1 a 1 que hace que no sea mucho más eficiente que el trabajo tradicional. También se recomendó la utilización de esta maquinaria para proyectos de infraestructura un poco más grandes del ejemplo que seleccionamos, que es un proyecto más de contexto urbano, Y un poco la razón detrás de eso es que en los proyectos que ya se ha utilizado hoy en día de minería, hay menos obstáculos y eso también hace que el robot sea un poco más eficiente. El segundo ejemplo que analizamos en Lima fue para Megacentro, que están muy interesados en ver cómo se podía automatizar el mantenimiento de los techos de sus depósitos. Y hoy en día esta es una tarea que se hace de forma manual y lleva bastante tiempo y también es riesgosa porque obviamente tiene que haber un operario trabajando en altura, revisando los techos, y por eso no se puede hacer de forma muy frecuente. En general se hace una vez al año. Y la idea era analizar qué pasaría si utilizamos un dron de forma autónoma para sobrevolar los techos de los depósitos y poder recabar la información necesaria. Entonces analizamos este ejemplo de Exim, que en parte era bastante interesante porque puede explorar un espacio de forma autónoma sin necesidad de tener información a priori del espacio. Gracias a esto ya se ha utilizado también en proyectos de minería porque puede explorar una zona de forma autónoma sin necesidad de un operario cerca. Y las ventajas que vimos fue, primero que nada, que al ser un producto bastante compacto y los drones ya se han comercializado bastante, se podría obtener un payback de la inversión en 2 años para el contexto de Perú que analizamos. Y podría reducir el mantenimiento anual, el costo desde $1.36 a 0.67 por metro cuadrado. En parte, estas eficiencias en cuanto al costo se darían porque si tenemos un dron podemos hacer monitoreos más frecuentes del techo y encontrar la oxidación en etapas anteriores, que hoy, en el método de hoy en día que no se hacen con una frecuencia tan elevada. Básicamente los estudiantes también descubrieron que hay 3 tipos de eventos que requieren mantenimiento, y cuanto antes podamos encontrar estos eventos que requieren mantenimiento, más barato es la reparación. Y no voy a entrar en detalle en los 8 proyectos restantes, pero para darles una idea en general de cuáles fueron los resultados en cuanto a seguridad, calidad, cronograma y costo, vimos que en todos los casos los robots pudieron reducir las tareas más repetitivas y las posiciones ergonómicas más incómodas. En 2 casos que son más de tecnologías asistivas como exoskeletons, las condiciones como peligrosas de la tarea no se modificaron, ya que, por ejemplo, podemos tener al mismo trabajador trabajando en altura, pero se encuentra con un soporte para realizar la tarea, pero sigue estando en altura. En cuanto a calidad, medimos la precisión y también el retrabajo utilizando robots versus el método tradicional. Y en 8 de los casos vimos que la precisión se mejora en un rango entre 25 y 90%. 2 casos no se pudo analizar de forma cuantitativa los beneficios en la precisión. Uno fue el caso de la maquinaria autónoma, porque en realidad se entiende de que va a ser bastante similar a la calidad que se obtiene hoy en día con la maquinaria. Y el otro ejemplo también fue el de los exoskeletons, porque no había suficiente data experimental sobre si el uso de estos sistemas de apoyo puede hacer que el obrero también sea más preciso. Y también el retrabajo se redujo en promedio un 62%. En cuanto al cronograma de obra, vimos que también en promedio se alcanzó una reducción de 2,5 veces. 8 de los casos mejoraron el cronograma, en un caso se mantuvo igual y en otro caso se incrementó con el uso del robot. Y ahí podemos ver un poco más el breakdown del schedule. Y en cuanto al costo también en promedio vimos una reducción del 15%. Y acá hay casi, o sea, 60-40. En 6 casos se redujo el costo, pero en 4 se incrementó. En general, en los 10 casos que vimos, en 5 el robot fue mejor que el método tradicional en estas 4 categorías. Y encontramos muchas eficiencias en, por ejemplo, este tipo de robots que son para exteriores, muy compactos, fáciles de usar, que no requieren como algunas condicionantes especiales o setups o cambios al proceso muy grandes. Y también pudimos ver en estos proyectos, bajo qué características y qué circunstancias hacían que las aplicaciones sean beneficiosas, y en ciertos casos los resultados también se vieron influenciados por el costo de la mano de obra y qué tanta mano de obra se encuentra disponible, cuál es el costo de la tecnología, qué tan fácil es pasar a digital la información de la tarea y cuál es el proceso para realizarlo. Y por último, también dependiendo de distintos modelos de negocio para utilizar el robot, muchos de los robots que estudiamos, creo que 8 de los 10 casos, se ofrecen como un servicio en vez de un producto que la empresa tiene que comprar y realizar una gran inversión en el principio. Y la idea de esto es poder cuantificar, por ejemplo, alquilar un robot por mes o para un proyecto y cuantificar las horas y pagar por esas horas, que eso reduce un poco el riesgo de la constructora de invertir en algo tan caro como el hardware. Y algunas de las fuerzas que vimos actuando a favor del uso de robots en estos casos fue primero la necesidad de la construcción para optimizar productividad y costos. Segundo, poder mejorar la seguridad también para atraer a nuevas generaciones hacia la construcción. Y también relacionado con la falta de trabajo calificado para ciertas tareas, especialmente las tareas que son más peligrosas. Por otro lado, algunas de las fuerzas que actúan en contra del uso de robots en construcción fueron la resistencia al cambio, costos, cambios en los contratos, especialmente en algunos casos pasamos a tener un subcontratista a 2, que el trabajo se subdivide entre el subcontratista tradicional y el robot, falta de información o condiciones del sitio que no son predecibles, y por último también la decisión del diseño y cómo eso se incorpora a la decisión del sistema constructivo. En muchos casos, decisiones que tomamos en la etapa del diseño hacen que después el robot no sea tan compatible, y si supiéramos que vamos a utilizar el robot con anticipación, podríamos haber hecho pequeños cambios en el diseño de la obra que faciliten su uso luego. Entonces, ahora nada más para concluir rápidamente, algunos de nuestros próximos pasos en la investigación en realidad están relacionados con este último punto, de que nos dimos cuenta de que en muchos casos valía la pena entender desde la etapa de diseño o preconstrucción cuáles son algunas de las variables claves del robot para poder facilitar desde el diseño su uso y que tenga una mejor producción. Por ejemplo, en el caso de hacer las perforaciones en concreto, vimos que podría haber un beneficio en la productividad de un 10% si unificábamos el tipo de diámetros que se usaba entre los 4 subcontratos. Y esto claramente no es un cambio estructural o de diseño importante para el cliente, pero a la hora de evaluar el sistema constructivo sí podría tener un gran impacto. Entonces nuestro proyecto se está enfocando en diseñar una interfase para el usuario que pueda representar el ambiente de la obra y también la forma en la que el robot va a interactuar con el ambiente físico. Esto nos puede ayudar a reconocer qué parte es accesible para el robot, qué parte vamos a tener que seguir haciéndola de forma manual, en dónde puede llegar el robot, qué tipo de cambios podríamos realizar. Y claramente en algunos casos no vamos a cambiar capaz las dimensiones de un local porque queremos construirlo con un robot, pero en otros casos, como el ejemplo de las perforaciones en hormigón, que es algo que no impacta ni lo estético ni la funcionalidad del espacio, sí podríamos realizar esos cambios, pero tenemos que tenerlos en cuenta con cierta anticipación. Para terminar, nada más me queda agradecer a SAIFI y a la Universidad de Lima por apoyar esta investigación, y también a las conexiones con Productiva, Megacentro, Omar Alfaro también de CITIC por ayudarnos a hacer estas conexiones con la industria y contar con el apoyo de forma remota para los proyectos, para los casos de estudio que mostramos hoy. Quedo a disposición por cualquier consulta en el panel o más tarde en la conferencia. Muchas gracias.
Agradecemos a Cintia Brosque por haber tenido la amabilidad de presentar su exposición de manera grabada. Como ya lo mencioné, ella va a poder estar en la ronda de preguntas por si alguno tiene alguna consulta hacia ella. De hecho, muy interesante su exposición sobre la aplicación de la robótica en la construcción y un poco la investigación que está desarrollando con Martin Fisher. Bueno, continuando con el programa, pasamos a la última ponencia de la noche. Invitamos a René Morcos, fundador y director ejecutivo de Alice Technologies. Él enseña en el programa de doctorado en gestión de la construcción de la Universidad de Stanford y ha trabajado en proyectos de construcción en todo el mundo. Su experiencia profesional abarca desde trabajar como gerente de proyectos en Afganistán hasta impulsar la ingeniería de automatización en un proyecto de expansión de una refinería de gas en Abu Dhabi. Esta última ponencia será realizada en inglés, por lo que, como ya lo había mencionado anteriormente, pueden activar la opción de intérprete en la parte inferior. Muchas gracias y adelante, René.
So, every year, 10% of world GDP is managed around the world with this. Scheduling and estimating form the two major pillars of construction management. These two technologies haven't changed since the 60s, in the last 60 years. Scheduling and estimating are still based on what I call automated technology, right? Technology that is effectively a glorified spreadsheet, right? So that causes several problems in our industry. As you know, our industry has an average profit margin of 3%, right? This is an important one. Resources today are asserted or figured out in the estimate, right? But the schedule is what is executed. So resources are figured out in your estimate, where you figure out the number of cranes, number of crews, overtime, so on and so forth, but you go and execute your schedule. This disconnect leads to substantial problems on a construction site. There's a high impact of uncertainty, right? And so in our industry, when you're late, right, it results in lawsuits, liquidated damages, and so on and so forth, right? And there's no way to really mitigate those impacts. You can't generate options, simulations. There's no way to ask a construction management system, what is the best way to mitigate an impact? Today, all of that information sits in somebody's head. Somebody has to manually figure out what is the best course of action, right? The tools we have support those decisions, but they do not help, I guess, calculate those decisions. And finally, there's no systemized knowledge transfer, right? Today, most of the knowledge about how to build something is again captured in someone's head, right? Just like we need to figure out the problem in our head, we have to maintain knowledge of prior construction projects again in our head. If somebody leaves the company, right, that knowledge tends to leave with them. As a result, McKinsey & Company's report that came out, I think 3 years ago at this point, states that large construction projects are typically 80% over budget and 20% longer than scheduled. And so what have we done about it at Alice Technologies? And so what is Alice, right? And what on earth is generative construction? How does it work? Well, to introduce the technology, right? What I'd like to do is I'd like to introduce these 4 levels of digitization, right? The first level is static, right? The second level is automated. The third is parametric, and the fourth is generative. These are levels of automation in our field that I've developed to help myself understand digitization in AEC. And so the static level means drawing something on paper, right? The next level up, which is automated, is the way to think about it is what I used to draw on paper, I now draw on the computer, right? So AutoCAD, estimation technology, CPM, these are all automated technologies. The next level up is parametric and generative. And so if you don't know what parametric technology is, you'll be an expert in about 30 seconds. To explain parametric technology, I'll use an example of parametric design. Let's say you want to draw a cylinder. you would draw 2 ellipses and 2 lines. Let's say you want a smaller cylinder. You have to redraw. Let's say you want a bigger cylinder. Again, you have to redraw. You have to redraw the object every time there's a change, right? With a parametric tool, you have a height and radius, right? You change the parameters, right? And the object will automatically redraw itself in the tool. As you can imagine, this is useful when you're designing a car engine, right? Because somebody can say, hey, change the pipe diameter from 1 inch to ½ inch. Back in the day, you'd have to change all the cross sections, all the elevations, all the quantity takeoffs, right? And simply hit the button. Today, you simply hit the button, change the parameters, and the tool redraws the object. Same with a building, right? If you want to move the staircase, back in the day, I had to change all the cross sections, all the elevations, all the quantity takeoffs, the 3D model and everything else. With a parametric tool like Revit, you move the staircase and the model updates itself. You can move the window and the hole in the wall moves as well. And so this sort of revolution has been happening in our field over the last 35 years, right? We started with static, moved to automated, went to parametric, and then finally now we're at the generative design level, right? The difference between parametric and generative design, right, is that in generative technology, you simply need to, the tool changes those parameters for you, right? Instead of you manually having to change the parameters, you tell the tool, hey, try all parametric values from 0 to 10 by 1 foot increments. And so the tool generates lots and lots of options by itself, exploring them. And you tend to say, maximize the power output of the engine or minimize the energy requirements of the building. Right? What we have done at Alice is the world's first generative construction tool. That's what Alice is. It is a generative tool that enables you to change construction. How does it work? Well, it actually works in 3 main phases. In the first phase, you set up a plan, a rule set that governs your project. And this is one of the big things that we've done that hasn't been possible before. We've separated planning from scheduling. We've separated the rules that govern your construction project from the solution to those rules, right? So when you generate options this way, right, what you can then do is analyze them in detail, right? And so you set up the rules to a construction project, send it to the simulator, which crunches those rules for you, right? And then analyze results to see which of those solutions are the ones you want, right? Notice when you look at this graph, what the humans are very good at doing is planning, right? Humans are very good at changing the rules that govern a construction project, right? Once you change those rules, you send them to the simulator, right? And that crunches it for you. The machines are very good at doing this piece, which is crunching the rules, generating millions of options. The humans, again, are the ones that interpret the results. You tend to see that pattern with most sort of technology that's out there, right? The human stops being the entity that does the crunching and instead becomes the entity that sets it up and then interprets the results, right? So the question is, why do it this way? Why separate the rules from the solution? Because we used to do this in one go. The bar chart, the Gantt chart, right, or the estimate has everything sort of looped into or crunched into one step. The reason's simple. It's because it's generative. You can now change anything you want in the rule set. You can add a crane, reschedule, change the overtime or add a delay, and then hit the button and resimulate, right? This allows you to explore for the first time in the order of, say, 600 million different ways to build a given construction project in the course of an afternoon, right? What we've realized, right, is that the ability, right, to change these rules, right, enable you to explore, millions of options almost instantaneously, right? So the question then becomes, what can you change, right? Or how does the system work? What can you change? And the answer is you can change pretty much anything you want. It's been 2 years at this point that we haven't encountered a constraint we cannot model. Precedence and crews, these are parameters you can change with today's technology. But available space, sequencing of crews, materials, consumable, reusable, supplyable, cranes and equipment, location of cranes, movement of cranes, radii of cranes, construction duration, production rate, prefab versus on-site. Design, that's a really big one. You can now upload a new design, copy the design from the old version, right? Or copy the rules from the old design and then hit reschedule. Overtime, 24-hour shifts, multiple calendar shifts, and delays, right? All of these things you can now change on the fly inside the Alice system. So with that, let me show a quick demo of the tool itself. Forgive me, my screen sometimes gives me about a 30-second lag. It started happening a few days ago, so my apologies, but a little bit of patience, please. And while this is loading, I'll jump into one of the case studies that I have here. And so this is a tunnel project case study, right? And so what you'll see is what we've loaded into the system is a $800 million tunnel that's 2.8 kilometers long. There's 3 shafts for entering that tunnel. Access to one of the shafts is 6 months late, and that causes us a 165-day delay. We've tested 4 different scenarios or digging scenarios. Right? We've tried to add a tunnel boring machine, resequence, change the direction of the tunnel boring machine. And so with Alice, we've developed a construction solution that reduced the delay from 165 days to 24 days by exploring about 6 million sequences. And we found that you do not need to add a tunnel boring machine in order to shorten duration, right? When we set up the problem, some of the questions that we tried to ask are, what is the true magnitude of potential delay? What does the delay impact look like across the project? How to work around the constraints caused by the delay? And then what's the best way out, right? Do I need to add a tunnel boring machine or alternative delivery method, right? And what you'll see here is that the solution, right, is counterintuitive. Adding a single, a tunnel boring machine does not speed you up, because what we realized was the limited constraint was removing dirt from the tunnel and not digging, right? And so we could recover about 90% of that delay by resequencing instead of spending 13 million euros, additional 13 million euros to buy a tunnel boring machine, right? And so you can see the results here, which is scenario 1 is add a tunnel boring machine. There's no improvement in speed, but an additional cost, right? In scenario 2, again, which was turning the tunnel boring machine around, also didn't improve speed. With scenario 3, which was using drill and blast methods and resequencing, looking through 6 month sequences, reduced the duration or the delay to 25 days from 165. So those are sort of the results, what we could do. With that, let me kind of hop into the demo that I wanted to show. And so, okay. I can reload this. So what you'll see here is that we upload a 3D model of something we want to build. And again, there's 3 phases to the software, right? Again, thanks for your patience. The screen's kind of logged back on. And so what you'll do is you'll upload a 3D model of something you want to build. You set a number of rules. Those rules are relatively simple. The first rule is which element is physically supported by which element. So you can see here that the yellow pier cap is supported by the piers and supports the roadway. So rule number 1 is physical constraints. Physical constraints are an important rule in construction. Rule number 2 is grouping and splitting, right? And so you select the columns that you want to group, and you sort of say, these are going to be built in one go. And rule number 3 are what we call recipes. And so what I need to do is I need to tell the software, this is how you build a pier cap. And so to build a pier cap, I have to put some formwork, put some steel, pour the pier cap, cure the pier cap, and strip the pier cap. And what you'll notice is that each of these tasks has some resources. I have to put up a carpenter crew. I need a mobile crane and a duration. And that duration, as you can see, is parametrically calculated. The big difference between this generative approach and anything else is you create that recipe one time, apply it to all the slabs. Or you create it one time for the piers, apply it to all the piers. You can create 30 recipes. Those recipes generate about 5,500 tasks. When you can see then, and this is the big deal, is step 2 is generating options, right? So the humans are very good at understanding construction, gut sense. I know the rules. I'm going to tell the machine the rules. That's what I'm good at. Let the machine crunch the rules for me. And this is a big deal. Each of these dots is a different way to build your project on a cost and time calendar. Each of these dots is a fully resource loaded simulation. And you can see that I can build this project as fast as 767 days and as slow as 936 days and everything in between. You can see that somebody started looking at the baseline schedule, updating with a locked sequence, updating with progress update, April 9, optimize equipment. I've increased my drill rate to match a new production rate that's coming from the construction site. I've limited my workforce to 40 people because of COVID and so on and so forth. And just to give a brief idea, all it takes is you hit the what if button, on the crane, for example, go to equipment, you change that 4 to 1, you hit run scenario, and that's it. The software will now resolve 14 constraint types across 5,500 tasks for the duration, 700 days of the project. Then you can click on these dots and expand them. And what you'll see here is an automatically generated Gantt view, a Gantt chart that you're very familiar with. This is generated automatically by the computer and a 4D model of what you want to build. This has not been done before. Also, what you can now start doing is advanced analytics, right? You can, for example, see that my carpenter crews, I have 3 carpenter crews available, but I only use the 3rd crew in one day. I probably want to rerun the simulation with 2 crews. These are the sort of questions you can start asking and answering, right? I've got about a minute left, and so I can show you a solar farm project that we've done. You can kind of see here, for example, this is the dates at which you energize your circuits, right? So you can see here that the first day of energy circuit is 20 April. Rerun the simulation and tell the software to finish milestones faster. And you can see clearly that you're now energizing the circuits on 22 February. You can optimize for multiple objectives: cost, duration, time, minimizing total number of crews, specific crew number, and so on and so forth. Like I said, you can generate about 600 million different ways to build a given construction project and tell the software to select different objectives that you want. And so that's sort of it. I think that I'm on time, which was the 25 minutes that was allotted, but please let me know if that's not the case.
No, you actually have a little more time if you want to continue, or if you want to end the presentation here, it's okay as well.
Oh, great. How much time do I have?
You have around 10 minutes, probably.
10. Wonderful. I can show the examples that I wanted to show. Okay. Elevated railway. This is another project that we ran with Alice, right? In this case, what we did was an elevated rail project. This is in Canada. The major question on this project is the winter weather, right? And so what they needed to figure out is the winter shutdowns. What would their schedule look like if the winter was more severe, less severe, right? And each one of these decisions would affect the resourcing, the number of crews, the sequencing, and so on and so forth, right? And so what we did was we uploaded into Alice, created sort of these calendars that were different sort of weather patterns, right? And we ran the simulations, and we're basically able to tell the contractor that, so using Alice, we figured out that if they continued their course of action, that there would be a 200-day delay. Right? If they did nothing different, it would be 200 days late. We then looked at sort of 500 different scenarios in Alice, right? 500 different ways of building the project, right? And we figured out that what you need to do for this job is to increase the capacity of the carpenter crews by 12% and increase the capacity of formwork by 50%, right? These two changes resulted in a 26% improvement in crew utilization, right? And with that, the contractor, it's actually public knowledge now. So Parsons won the $2 billion Edmonton Rail project by minimizing the contingency in their bid with this technology, right? So, I can also show, say, results. So this is actually another view of that solar project. So what you'll see here is the target duration is 297 days. Now remember how the estimate figures out the resources, the schedule is what you execute, right? And so what we did was we took the resource numbers out of the estimate, and we ran them through the simulation. Effectively, we took resources out of the estimate, resource loaded the schedule is one way to think about it. And the first thing we discovered was that there's a 48-day delay, which we tend to find on most projects that we look at, which is that the disconnect between the resource allocation and the estimate and the lack of resources in the schedule results in a delay. Now, somebody on the construction site said, hey, but my project won't be 48 days late. I said, why not? And the person said, well, because I'm on site, I'm going to be seeing that there's a delay that's occurring, and I'm going to be mitigating it on the fly. I'm going to be look outside in the construction site and think, hey, I need to add crews, or I need to add cranes. And I said, yeah, that's correct. From my experience in construction, that's exactly what it feels like when you're in a construction site. You're putting out fires on the fly. You're trying to figure out how to mitigate delays on the day of, right? And so what we did was we took that information, ran it through Alice, right? What we did was we flooded the software with resources. We said, hey, what happened if you had infinite resources, right? And so Alice, it's what we call the saturation run. And so Alice found a solution, right, that's 276 days, right? So not only did we match their target, we beat their target duration. Then the flip side is, okay, Alice, what I've told you is find the fastest completion time and, use resources very ineffectively. So Alice did that. Now I know that there's a 276-day completion time, but the cost has increased substantially from 50 to about 57 million. So the next thing you do is you change the objective function. Say, okay, now please reduce the cost, right? Reduce the cost. And so You can see here that now we've told the software to start being smart about the way it uses resources. You can see that now we've taken the cost, still 267 days, but reduced the cost to sort of 41 million bucks. This is, once you've set the system up, you can sort of very rapidly start doing these changes. And so another use case that we're seeing with this approach is 3-week look-aheads, right? I was called into a construction project recently in the US. One of the major issues is how do we communicate to site what we need to do? Well, with the system, it's just a filter, right? What they want to know is who's working, which sub, how many people per block, per day, per week. And this is a specifically created for this project. This is a top view of a solar farm. You can see how many people are on which location over the next 3 weeks, right? And they had a limitation to the number of people because of COVID, right? And so that's how you can do it. And I guess the last thing that I'll show you is how, right? How is it that we found a solution that's faster or cheaper, right? And this is how. It turns out that in your DC electrical crews, you have to go from 1 to 2, right? You have to add 1 crew here. You have to add 1 crew here. You have to add 4 crews to these module crews, right? And you have to not decrease these ones, which is why we made it red. But you can see that in their original solution, right, with these P6 calculations, they have 62 crews, right? With our solution, even though we added 1, 1, 4, right, and left this the same, we have 19 crews less. So what you're seeing is with the tool, you can figure out exactly where you need to add and where you need to remove resources, right? And so that's how you sort of gain those efficiencies, right? Your crew utilization tends to jump from around 55% with inefficient solutions to somewhere around 62, 65%. There's a 5 to 10 increase in the asset utilization for your resources, and that's how you get these additional sort of efficiency jumps. So that's sort of it for me. I know I'm a little bit early, but thank you for your time, and look forward to the panel and the questions.
Thank you so much, Rene, for your presentation. Very interesting how Alice managed to do this type of reducing time in the project and actually make it a little bit more efficient. So yeah, we are about to start the questions roundtable. And first we're going to start with, is it okay with you if we start with you for the questions?
Yeah.
Rene?
Yeah.
Okay. Okay. So the first question for you is, you have mentioned that Alice understands concepts as available space, available material, and design options. What do you think is the next big challenge in terms of a key concept that Alice must learn in order to optimize its performance?
Well, that's a great question. I think the next frontier for us from a theoretical perspective, right? And so from simply like a feature or capability perspective, it will be communication via the tool, right? It'll be integrating with existing systems such as supply chain, procurement, engineering. So those are sort of feature specific things or capability specific things. But the question was more about what is the theoretical frontier that we're going to work on next. I have 2 answers. One is the definition of criticality. And so our current definition of criticality is based on critical path method. And so people always ask, what are the critical tasks or what are critical tasks? With Alice, what you can start unlocking is what are the critical tasks, but what are the critical resources? What are the critical calendars? What are the critical relationships? And so the definition of criticality is one of the next things that we're addressing, right? Which is not just why is something critical, but what can I do to make it less critical, right? And then the other one is, I think that the next theoretical sort of frontier will be learning how to create those recipes by itself. And so giving you suggestions on what those recipes could be, right? And effectively, today the plan is very manual, but with the tool or with the approach, what I'm foreseeing in the future is that the tool will be able to help substantially with the planning, not just with the simulating or the scheduling. So that's it.
Thank you so much for the answer. And last question for you is, you mentioned a couple of cases of study and how Alice reduced the time of them by simulating different ways to do in a specific process and actually watching the possibilities in a chart, which I think is very important because you actually can see what you're planning and all the different possibilities. But how long does it actually takes to decide which is the best option to use? I mean, is it just by choosing a specific option determined by the position of the point in the chart, or does it require a little bit more information apart from that?
So what's really interesting is that the software, as powerful as it is, and to give you an idea of what it's doing, 5,500 tasks, 14 constraint types, 700 days. Multiply those together, and that's kind of what it's crunching. We've managed to load problems into software that reach the limitations of modern computing capacity, which is really sort of interesting. But at the end, what's really interesting is that the tool is not very useful at selecting the best option. The tool can do mathematics. It will calculate the fastest and the cheapest, right? Humans rarely select the fastest and cheapest options because there's too much risk involved. And so that gut sense of analyzing multiple options and the risk evaluation across options, right, is what the humans are very good at. So that's, you still need the human to do the risk analysis for you.
Sure. Thank you so much for your time and for your answers. Bueno, para todos los que siguen y que estamos ya pasando a la ronda de preguntas, voy a darle el paso a mi compañero Álvaro Bazán para que pueda continuar con la ronda de preguntas con los dos siguientes expositores.
Muchísimas gracias, Rodrigo. Bueno, mi nombre es Álvaro Bazán, ya me presenté la sesión de ayer, donde estuve moderador, así que no me voy a presentar nuevamente. Nuevamente agradecerle a René por sus preguntas y también a los expositores por sus magníficas ponencias. Entonces, voy a empezar primero con esta pregunta para Juan Carlos Germano. Desde su experiencia, ¿cómo Augin, a través de sus modelos de realidad aumentada, podría reducir la latencia en la decisión y respuestas en las sesiones ICE?
All right. Do you hear me well? Just make
Yes.
sure. All right. When we built the application, we were really happy how the people get involved with the project because it's a real project. It's real information. It is accessible in a way that you have the model in your front like it's supposed to be built. You don't need to buy any equipment on using augmented reality today. And you can trust because precision today, even with smartphones, are on the millimeter precision. But not only using virtual reality in the ICE sections, but the use of augmented reality, since it's accessible, and also it's very nice to see something in your front, even though it's not constructed yet. But you can compare. You can compare with the room you are. You can share with the other colleagues that are working on the same page, and you can discuss since the mobile phone has sensors, and you can really analyze in the real scale from different angles. And sometimes when something is complex, that makes a huge difference and can be even better experience than the computer, for example. Extending this for the job site, since we are not discussing anymore with the people who do the project, it gets more clear because the people in the job site, they have a mission to complete. And since today's mostly constructions, they receive 2D drawings, and then they need to combine in their brain how that 3D model should be rendered, and they need to render in their brain. And I think one of the goals of augmented reality is that you can get all the people in the same page with a few seconds, because we live in a 3D world. It makes more sense to see the whole thing, how it should be built, right? So it's a matter of trust, getting the precision on what's the real size of that, and I guess really can contribute on the ice section and also the construction site. We are seeing so many people using augmented reality to discuss, analyze, and exchange ideas while they're having this experience. And I really suggest you to give it a try, all right? So I think it can be something complementary to the AEC today.
Muchas gracias, Juan Carlos, por tu respuesta. Y ahora voy a continuar con las preguntas para la arquitecta Cintia Brosque, que tenemos 2 preguntas preparadas para usted. Bueno, la primera pregunta que tenemos es, en su opinión, ¿cómo ve la implementación de robots de forma masiva en la industria de la construcción? ¿Cercana, lejana? Y en el caso de que sea esta implementación masiva, ¿cuáles serían los primeros robots o tipos de robots que serían potencialmente masificados en la industria?
Muchas gracias por la pregunta, Álvaro. Creo que la palabra masiva igual es un poco difícil. Sí, notamos el cambio que ya hubo en los últimos 5 a 10 años. Ha sido increíble el número de nuevos robots que hemos visto desarrollados para construcción. Y es probable que en los próximos 5 a 10 años también siga avanzando a medida que estas tecnologías van siendo más económicas y se vuelven más compactas y más fáciles de usar en el sitio. Entonces creo que en el rango de 5 a 10 años más vamos a seguir viendo este avance, especialmente en los casos, por ejemplo, de maquinaria autónoma, como el que vimos en la presentación, en el que podés tomar un equipamiento que la empresa ya cuenta con ello y no es algo completamente ajeno o un sistema totalmente nuevo, entonces es más fácil de implementar y nada más se agrega un módulo que lo hace más autónomo. Creo que ese tipo de casos va a ser una de las ramas que vamos a ver más implementaciones. Y luego el caso de como los single task robots para interiores, en eso también hemos visto mucho progreso en los últimos 5 a 10 años.
Okay, muchísimas gracias, Cintia. También tenemos otra consulta que han realizado en la caja de preguntas, que es, ¿han pensado en hacer otro proyecto piloto con el uso de robótica en alguna otra obra en el Perú? Ya que nos gustaría participar en un piloto parecido al realizado con Productiva. ¿Conoce alguna empresa que trabaja con robótica para trabajos en obra en Perú?
Sí, esa es una muy buena pregunta. El trabajo con Productiva fue en el marco de una nueva clase de robótica en construcción para alumnos de posgrado de Stanford y también colaboramos con la Universidad de Lima. Entonces, en este caso no es como el robot aún no se ha implementado en Lima, sino que fue el análisis de viabilidad del robot para un proyecto seleccionado en Lima. Y creo que los resultados fueron muy favorables porque al principio cuando nos planteamos esta idea dijimos, bueno, tal vez ya vimos que en Estados Unidos y en Europa estas soluciones sí están siendo económicas y viables, pero tal vez no estábamos muy seguros de cuál iba a ser el resultado si lo llevamos a distintas producciones, distintos costos, como puede ser el de Lima. Y sí vimos resultados que la verdad fueron muy buenos y mismo de parte de la industria había una percepción de que iba a ser más caro o mucho más lejano y una vez que analizamos los casos vimos que sí era posible. Así que creo que sí hay bastante oportunidad de seguir trabajando y entendiendo qué tipo de robots son viables para para países de repente fuera de Europa y de Estados Unidos o Japón. Y luego, en términos de qué empresas ya se encuentran, vimos, por ejemplo, Hilti o algunas de las empresas más reconocidas que están invirtiendo bastante en temas de robótica en construcción y son globales, entonces podría ser una forma de aprovechar el desarrollo que ya están haciendo en otros países y llevarlo a Latinoamérica también.
Muchas gracias, Cintia, por la respuesta. Tenemos una pregunta más para René. René, we have another question for you. So you mentioned everything about Alice. So if the application is actually available for public, how can we use it? How could we try it if we're a company or an entity?
Very easy. Go to alicetechnologies.com and then fill out a contact form, and we'll be in touch.
Okay. And in your personal opinion, which has been the hardest project to solve with Alice, like the one that had a lot of possibilities on it, or in your opinion?
I'd pick two. I'd pick the tunnel project I showed you, because I think that I was surprised at what extent we were able to model reality. And so what I was not showing was that the speed of the excavation of the tunnel in the simulation was proportional to the size of the tunnel and the cross-sectional area of the location and the type of dirt we were digging through. So that was one. Two, the digging was producing within the simulation soil that then was being removed from the tunnels. So those were two sort of steps that I thought were very sophisticated. And you had 5,500 tasks that you were sort of crunching, right? That, and then we recently did an oil and gas, a $700 million oil and gas facility that we modeled actually without 3D. We modeled systems, subsystems, sub-subsystems, and I think there was about 15,000 tasks that were resolved across the simulation. And so those two, I think, are the most sophisticated projects that I've seen run with Alice. Yeah.
Great. Thank you for your answer. Álvaro, creo que tenemos una pregunta más para Juan Carlos o Cintia.
Sí, me comentan para Juan Carlos Germano, ¿cuál ha sido o cómo ha sido en general la respuesta que ha tenido de las distintas personas que utilizan Augin en sus proyectos? No sé si ha tenido una retroalimentación, cuál ha sido los mayores beneficios que ha tenido en esta retroalimentación de su plataforma.
All right, that's amazing, because since Augin it's used for several options, we have so many different feedbacks, because in Instagram, where our community is more bigger, we receive messages every day of people thanking our job because they sold a new project in that day. Like, wow, I used augmented reality with my clients and they loved and they sold my project, and wow. We also see feedbacks since people are using the job site and they could really understand better what's supposed to be built. And even in our Instagram has a lots of videos that if you guys are wondering like, what I can do with this, I suggest you really take a look in our Instagram. You see several videos on different use cases of augmented reality. It's also used on visualizing some complex objects. Since steel, I don't know exactly in English the name, but the ASU, it more complex it is easier for augmented reality, because as more complex the model in a 2D drawing, the easier the augmented reality will help. It's also impressive how the clients, and you can put lots of types of clients, since the guy who is buying the apartment or the guy who is working together, they can really see the thing in the real scale, and it's shocking because sometimes it's so clear. You can walk around, you can have a perception with something that it's in the pocket of everybody, and it's no investment required. So Ogden is really focused on mobile phones. We don't want to know about expensive products of AR. The idea was always to bring in an accessible way this technology. Thanks.
Muchas gracias, Juan Carlos, por los comentarios. Entonces, ya para cerrar esta mesa de preguntas, quiero hacerle una última pregunta a la arquitecta Cintia. Primero, la pregunta es, usted mencionó un poco sobre los siguientes pasos en su investigación, ¿no? Que era aplicar un poco robots en etapas tempranas. Entonces, la pregunta iba dirigida un poco a ello, ¿no? ¿Cuál es el siguiente gran proyecto en el cual desean implementar robots desde etapas tempranas? ¿Y cuáles son los beneficios esperados de ello?
Es una muy buena pregunta. En realidad ahora estamos trabajando con HD Lab, que es una empresa también miembro de SciFi, y ellos están realizando un robot para demoliciones interiores, y en este caso nos estamos centrando en la primera parte, que es encontrar cuáles son las métricas que tenemos que utilizar cuando estamos analizando robots para construcción, porque en los casos anteriores nos dimos cuenta de que muchas veces era difícil visualizar cómo iba a interactuar el robot con la obra, y muchas veces no hay como buenas métricas para entender hasta dónde vamos a llegar, hasta dónde no, y con esta empresa estuvimos trabajando porque en los primeros pilotos ya encontraron que hay veces que llegan a la obra y se dan cuenta que necesitan una rampa, o distintos temas que se los podrían haber visto con anterioridad antes de llegar a la obra con el robot y encontrarse con esos desafíos. Hubiese sido mejor poder simularlo, y luego entender cuáles son los temas más importantes, y el próximo paso es poder ampliar a otros tipos de robots y entender si hay ciertas modificaciones y con cuánta anterioridad deberíamos de conocerlas. Y eso fue un poco el caso que mostramos de Hilti, pero también lo hemos visto en otro ejemplo de Obayashi que trabajamos, en el que para poder utilizar un robot que transporta materiales, que es como un forklift pero automático, pero solamente podía trabajar si había un tipo específico de elevador en la obra, y era un elevador que salía como aproximadamente, quiero decir, como $10.000, algo así, y la idea era que en verdad los proyectos que no lo habían previsto no tenían suficiente espacio o suficiente budget para ese tipo de elevador, y era algo que en realidad podría tener un efecto luego en la productividad en obra, pero era difícil si no se había considerado desde el diseño, y poder entender un poco mejor cuáles son esas decisiones claves para distintos tipos de robots.
Perfecto, Cintia, muchas gracias. Bueno, muchas gracias a los expositores. Antes de terminar, quisiera pedirles si podrían darnos una pequeña sonrisa para una foto final. Renee, I don't know if you can give us a little smile for a final screenshot of the conference. Ya. It's done. Ok. Bueno, agradeciendo a todos los presentes y a los ponentes por su tiempo, damos por finalizado el tercer día del Congreso Internacional VDC. Los esperamos el día de mañana a las 6 de la tarde, hora de Lima, donde trataremos el último y cuarto eje del programa VDC MA Proyectos. Muchas gracias y buenas noches.